Physics! Because science. Hey there, and welcome to How'd You Get That, where we solve all your math and physics problems. I'm David, and today we are talking about a subject that is near and dear to my heart. Today, we are talking about physics. Physics is a subject that covers a whole lot of different topics, from subatomic particles to the nature of light and the nature of gases, to how bodies in the sky work, like planets and stars and galaxies. We cover the widest breadth of topics, from the weird quantum soup to the graceful motion of planets and galaxies. So there's a lot to cover here. But that's why physics is so exciting. It's a broad topic that's full of new discoveries and investigation into how our universe works. But what links all these things together? What makes physics physics? That's a complicated question, but I like to think about physics this way. At its heart, physics is about the study of interaction. And at the heart of interaction is energy. When we look at any physical system, we can describe it using energy. From the energy that's involved in a car crash to deform the front and rear bumpers of a car, or the energy that's involved with the potential of a ball to roll down a hill, or the energy that's involved when an arrow flies through the air. All of these different situations can be described using the energy of the system. Energy, in simple terms, is the ability to do work. And energy comes in all sorts of different forms, from kinetic energy to potential energy to spring potential energy and electrical energy and radiant energy and sound energy, and all sorts of different ways that we can manifest this idea of energy. And because of this, all of these energies work together to describe the nature of a system. Take the simple pendulum. As I move the bob further and further up, it gains potential energy. Its potential to do work increases. And once I release the bob, it starts to move. Its kinetic energy increases, but as it moves, it falls down, which means its potential energy decreases. So this interplay between kinetic energy and potential energy is what describes the motion of this system. As it gains potential energy, it loses kinetic energy on the way back up. Then, as it reaches its next maximum height here on the other side, it stops. It has maximal potential energy and zero kinetic energy. But once it reaches that point, it starts to fall again. It decreases its potential energy and increases its kinetic energy. Again, this interplay between potential and kinetic energy cycles back and forth as the pendulum moves back and forth in its motion. All physical systems can be described using considerations regarding energy. And this makes energy a very powerful tool in describing physical systems. You might learn early on in physics how to use vectors and kinematic equations and forces and stuff like that. And though these are extremely useful and very important tools for us to know when we're studying physics, they aren't the whole story. When we start talking about a system in terms of its energy, since energy is a scalar and not a vector, it can make a complex situation much, much more simple. Interestingly, the Newtonian mechanics that we often learn in physics class is not the only way of describing physics. And I'm not just talking about like general relativity and quantum mechanics. I'm talking about other classical systems. And these classical mechanics formulations actually focus more on energy than they do on forces, like Newtonian mechanics do. These other formulations of physics, including Lagrangian mechanics and Hamiltonian mechanics, can describe a physical system purely in terms of energy instead of looking at it in terms of forces or vectors and things like that. These formulations tend to be a little bit more advanced, needing some multivariable calculus and things like that, but they are much more elegant, I think, than Newtonian mechanics. Newtonian mechanics obviously has its place and is extremely useful in certain situations, but Lagrangian or Hamiltonian mechanics also work in their own realm and make things much more simple if you know the math. We'll be covering Lagrangian and Hamiltonian mechanics later on, but we'll be focusing on Newtonian mechanics for now because that's what most of us study. But know that there are other formulations for physics, and ones that are really elegant in the energy world. So physics is about energy. How does energy transfer and transform as a system evolves? In the next episode, we'll be taking a look at this problem. But in the meantime, why don't you try it out yourself? Consider these three physical systems: a swinging pendulum, the Earth orbiting around the sun, and an electrical circuit with a light bulb attached to a battery. How are these three physical systems alike in the way that we describe them using energy? Think about it, try it out yourself, and I'll see you in the solution.